what we do there is really put on the criminal hat that is outside the Rabobank, sometimes the bad guy insider, usually the outsider. And we look at our organization in a way that, how can we get in? How can we get those valuables that the Rabobank holds? Information, money, and anything else that might be worth a criminal's time. And in doing so, of course, with full permission, it's not that we're a rogue team that just does this. It's our legit job. And in that way, we really hack ourselves in. And usually, technical computers, you know it, the green letters on the black screen, all that. Sometimes it's more physical. We break into the building to get in. That stuff as well. So that's a little bit of where we're coming from. But I want to make the difference a bit clear. I think most of the audience here has at some point dealt with pen tests, a pen test team for whatever you're running in production, for whatever you're developing maybe. And there's a clear difference between that. Where a pen test team will take your application, your stack, your system, and basically knock on every door to see, is every part of this secure? Is it trustworthy? Can we rely on this to be secure? What we do is the criminal way. We try to get the, well, we're IT guys as well, so we take the lazy route, but we try to get through all those systems that in each own are secure. We try to find the loopholes, the little things that were forgotten to get in. And one of the things we see often is hard on the outside and soft in the middle. It's often really difficult for us to get inside an organization. We got the firewalls, everything that is internet facing is double checked, triple checked, really secure. So it is hard to get in, to get that foothold in your organization, usually very difficult. What we see as well is once we are inside, it's almost like a playground for us. We really have to hack ourselves in, but once we are in, things can become quite easy in a way. Because I'm sure you've heard this as well at some point in your career. Yeah, but it's not attached to the internet, or there's no production data on here. It's only test bullshit data, etc. All those reasons why it shouldn't matter. But all those systems inside, for us, is still a system inside. It can be the one step to reach our goal. May that be the 10 million euros, the production database, or something else. There's hardly ever in operation a hack that we do where we don't compromise or need a test server, a forgotten debug system somewhere, an OTA machine, something like that. Almost always, they are part of the kill chain in reaching that goal. And that's often because they are old versions, they're forgotten, they're not taken care of, soft in the middle. And we have a little demonstration for you. Daniel built something really cool, and he'll show you one of the ways that we can get in and what that means. So I'm going to give the word to Daniel, and he'll take it from here.
Yes. I just want to make sure that you realize that this is something that happened once upon a time in Fantasyland. This isn't something that actually happened in this way. But there are a lot of lessons we learned here that are not specific to some flaw or some configuration mistake that adds up to the whole or the large issue at end. So I'm going to start off with a little overview. On the left you can see the bad guy. He's on the public internet. he doesn't have access to any internal systems or data. He can only touch like the websites that are outside and public facing. And on the right, we have the private internal network with all the servers, the internal websites. And as usual, there are some servers that are right on the edge of private and public, and they can talk with both parties. So for now, I, as an attacker, can only talk to the web server that is running on some server somewhere, but I don't even touch the inside of the network. But let's start looking. Let's start to find a way to see if we can start talking to internal stuff and see how we can access the bank's network. So once upon a time, I was searching on Google, seeing if there was anything interesting related to Rabobank. So we start looking for websites that are hosted by Rabo, and we see this weird debug status test page thingy. It has a URL of temp.test.rabobank.nl, so it sounds kind of testing and not really production environment. And if we start looking a little bit closer, we can see it's a debug test page of some sort. It shows us our IP address and 2 services that are running fine, apparently, Sentry and a test server. But nothing else that's kind of interesting. But if we look at the source code, someone has had some form on this web page that went to /proxy with the parameter of URL, but they've hidden it away a little bit, so if you just go to the web page, you don't see it. So let's try ourselves to go to /proxy with the parameter of the URL parameter of Google, and we can see kind of Google. It's not all fancy with CSS enabled, but it is Google. And here we can see a little bit more closely what the URL is looking like. And we can see that this test server apparently has some kind of proxy functionality, so we can ask it to go to a certain website, and that way it will go to that website and give us the response back.
And anyone on the internet can do this, right?
Yeah.
Yeah.
So it's just open to everyone. As many of you will probably know, there's also this special IP address that specifies that we want to connect back locally, localhost. So if we try that IP, the 127.0.0.1, we can see the same debug test page, but now the requesting IP is localhost. So apparently we can also make requests internally and not only to the internet. So this means server-side request forgery. And that basically means that we can trick the server into making requests that it wasn't initially meant to be doing. In this case, this means that we can make a request to the server itself. So just as a quick overview, this is the situation we just tested and which worked. We can make the server request internally to its own website. But in theory, we could also make it perform requests to other servers within the network. So we could start looking for other databases, websites that are running internally. But for now, we are going to start off with trying to see if there's anything else running on that server. So we have this fancy script, which we can give the URL to with the parameter to test, and we specify that we want to do a local port scan. And it says to us that port 80 is open, which will probably be the debug test server that we saw earlier, but also port 8080 and 9000. And if we go looking for what's actually running on it, we can see Sentry, which we saw before, and we can see a directory listing with 3 files, the server, testserver.py, and just so it's clear, you can see that it's basically just the local host IP address with the local port specified. So we're not going to standard 80, but to the other ports.
That's basically what your script did, right?
Yeah.
Just try each one.
You can just make it try the local IP addresses with all kinds of ports or other services that are running on it. So we could try to reach internal IPs over different ports and just see what happens. That's also not limited to HTTP. It can also be FTP, for example, if the server is configured in a way that it can actually make those requests. But a lot of times with server-side request forgery, it can't do it because it wasn't expecting something else that made these types of requests. So now we can see the sentry and we can see a login page, but don't have credentials or whatever. It was just a quick search on Google. So let's try to read out these files. Specifically, I'm interested in the server.py. And if we try to search for it, we can see it tries /server.py, but that won't work because that's the original debug test server. So now if we go back and we append it to the URL of the proxy, we can see that we actually get a response back. And this way we can also see on the top right here, /proxy. So it seems like this is the source code of the initial debug test server that we found. So if we now try to make it a little bit more pretty so we can actually read it, we see that it's just a basic Python Flask server that's running. And it's serving the debug.html. But we can also see two more interesting parts. A read file test route that we didn't know of before, and a relay cookies something. And if we read through it a bit, we can see that it actually allows us, if we specify that we want to relay our cookies, it will relay the cookies that we give to the server through the proxy. So it might be useful if we can trick someone into logging into our like Sentry environment, and we can maybe steal the cookie and then give it to the internal one through the proxy. But let's try the read file test because it's low-hanging fruit. Let's just see what happens. So we try the most basic file that's on every Linux system, etc password-d, and we can see we get a response back. So we can read.
What do we see here? A whole lot of text.
Yeah, it basically is a file where back in the day the password hashes of the users were stored. Now it's in a different file, but it's a file that's always there on Linux systems. So it's one of the easiest targets to check if you can actually read arbitrary files. And just so it's a bit more clear, we can see we now make a request to the read file test route with the file parameter, and we can just input any file that we want. So now, we can make requests to the internet and locally on behalf of the debug test server, and we can read files from the web server. So what do we do next? We go back to the start. So we start looking at Sentry. What actually is Sentry? Some of you might know it. It's some platform that you can use to send crash logs to, and then if some user crashes your application, you get the crash log back, and you can see what happened and why it happened. So a lot of developers will probably have this running somewhere. Maybe they have their own one, maybe they have a central one. And it's quite a large project company. It's worth over 200 million, quite a large number of huge companies use this. But if you start looking more into it, you can see that it's not actually that secure. It's built on a really, really old Django version. And as some of you might know, with the pickling in Python, that if you don't verify what you're getting back, you can execute arbitrary code. And we can also see that in the Django documentation. If the secret key of the project is not kept secret, and you're using the pickle serializer, that basically means game over. I can execute anything I want on your system. So they're starting from Django 2, they're moving away from it, and they now use the Java's or the JSON serializer by default. But because Sentry is built on old 1.6 Django, they used the pickle serializer.
And this is really our way of working. Finding stuff we've never dealt with or heard of, and just Googling what's wrong with it.
Yeah.
and abusing that, you know.
Yeah, we don't assume that because it's just a big product or a big company that they will automatically spit out secure code, because more often than not, they won't. So now we know we have Sentry. We know we can relay the cookie. Now the only thing we need is the secret key. So we start looking in the system, and eventually we find a configuration file that's located in opt Sentry. We can use multiple techniques to just brute force and see what happens. And if you look really closely, right there, we see something that resembles a secret key. So now, we basically have all the ingredients we need to make Sentry execute our code, because it's using the pickle serializer. So now we have this magical script on top that we can give the secret key and IP address, and it will generate a cookie that will make Sentry connect back to us with a normal command shell. So if we start up our listener, that will receive back the connection, and we generate the cookie, we can see here that I use the relay cookies parameter as well in the URL to relay the cookie that we give to the proxy. We need to set Sentry SID to the evil cookie value. And if we go to the login page, again, you can see we get a shell back.
And this is really what we do often, right?
Yeah.
It's not that we connect or SSH into the servers. We most of the times trick the server into SSHing to us.
Yeah.
Much easier, firewalls, etc. Outbound is almost always allowed.
Yeah. So it's often, as Sebastian said, it's really hard to get in, but once you're kind of in, it's really easy to get out, because employees need to connect to the internet. Servers might need to get updates, for example. So they need to be able to connect back to the internet as well. So it might be that because we can test this locally, we can just spin up our own Sentry server and try what works and what doesn't. It might be that it's hardened in some way, and that we need to pull up some tricks to eventually make it connect back to us. But it's open source software, so anyone can do it, anyone can try it. And as you can see, it just works. One limitation is that we are in a Docker container, but there are also, it's at least, as you can see in the overview, we can now connect directly to the server. So we're not requesting anything through the website. We're communicating directly with the server. We can execute commands. So we basically moved ourselves into the position of that server, and we can now start talking directly to internal systems with a lot more freedom than what we had before through the proxy, because, of course, that is limited. And now we just have some server that's running, and we can execute anything we want.
Yeah, we don't want to hack this way in all the time. Basically, you made backdoor eventually.
Yeah. So we can, of course, do this repeatedly until Sentry gets an update and it's fixed. They are working on a fix, by the way. It's not that it isn't known. But there's a transition time, so current up-to-date Sentry systems still accept pickled cookies. So if you know the secret key, go ham. But you didn't hear that from me. So yeah, we're in. Now what? We can start monitoring data that's flowing around on the network. We can start talking to other systems directly and see if they are using weak passwords. Maybe there's another debug database somewhere in which people have used admin, which still is used, and there are other credentials in it that are reused somewhere else, or that give us an indication of what type of passwords developers in a specific team will most likely use. Maybe they are a fan of some TV series or whatever, and they use characters from Family Guy as passwords.
What are typical things that you would look for, right? Once we get in, it's gently looking around. What is there, and what can we learn from this, and what can we just use? We're ethical hackers, but we try not to hack.
Yeah.
If we can just browse a page and there's, how to log in on some test server somewhere with username, password. Why would we hack ourselves in if we can just log in pretending to be you or you know?
Yeah. So in that way, test environments are most often the ones that are overlooked because it's an internal test environment. So what are the odds of your colleague trying to log into your database that you only use for testing? So why use a strong password? And of course, I know strong passwords. You've been told, everyone knows that we should use strong passwords, but it's just that one test server, so why bother? So these are some of the lessons that we are trying to teach and preach. Separate development and production environments, because we see sometimes that some production server has a test server running because it's just the one quick test that we need to do, and then it's forgotten and it's just been running there for 4 years and no one has been looking at it until we do, and we gladly make use of mistakes or misconfigurations from way back. So if you test, please clean up, please, or maintain and secure test environments. Even if it's just something that you're going to use on Friday afternoon and forget over the weekend, don't assume that the last line of defense is the outside. Because once we're inside, we might have a low-level access to some server somewhere, and then some production or some test server that's in the network becomes the last line of defense.
Yeah, definitely be also hard on the inside. I'm sure you've all heard about zero trust, etc., but there's a difference between complete zero trust or being completely open on the inside. And I understand you need to find a balance in that, but what we really often see is that this was quite a difficult hack to get in. You know, we had to know all those tricks and how to do it. And if Daniel shows it like this, it seems really easy, but to figure it out without no knowledge of what's going on is really quite difficult. But once we get in, it really is no exaggeration that we browse around and you might have an internal Jira that is open because you need to cooperate, Confluence, etc. And we all write so much documentation for those colleagues that need to do that work. But there's also, at some point in your career, somewhere you're going to get a hacker somewhere. Really think about what could the bad guy, even if it's your colleague that is about to get fired and he wants to break everything that he can, or it might be some scary dude from somewhere around the world, what could they do if they get here? And really think about the consequences if that happens. Do you really want to put all your usernames and passwords for all your test environments in Confluence? It's easy, it's probably not the best space, even though it's just test. If we can log in as any normal user can, if you have any defense team, like a blue team, your SOC, your whatever, is monitoring your security, if we hack ourselves in, we run a big risk of being detected. But if Daniel finds a username and password and he can just log in as a normal user doing normal stuff, yeah, you know, it becomes super difficult to find out what's going on because it's just a legitimate user.
Yeah, how often do you notice like the last login on some web server or some testing server somewhere is over the weekend while you were off on a boat or with family, and we were working and trying to figure out how your server works and how it communicates with others. But we do get the message that last login was over the weekend, but there's no red flag like, hi, do you really know that this was you because it was over the weekend? That doesn't happen. And
especially not in test.
Yeah. So, and also, Sentry is quite a large platform. It's worth over 200 million. They claim it's used by Microsoft, by Google, by almost all the big names in tech. And they will probably have more than one server somewhere. They might have one main one and some test ones. And I just need one to be, the secret key needs to be exposed. If you enable or leave debug enabled and don't disable it yourself, if you have a web form somewhere that crashes if I give it weird input, it will spit out the secret key. So I don't even need to be able to read files on the system. It just hands it over. There was this one case with Facebook in 2018 where there was this weird server somewhere that was running Sentry and had just the password reset form. And if you kept resetting your password, it would eventually crash. And it would spit out the secret key just like that. And then that way, you have your initial access. And that guy got like $500 or $5,000 bug bounty. But imagine if it wasn't a good guy and he just went on into the network and saw what happened. So large application, small application, doesn't really matter. There's always gonna be a mistake or a misconfiguration somewhere. Maybe you didn't even realize that it's there because the developers didn't know it. But if someone looks hard enough, they will eventually find something. And it might be big, it might be specific, but large application doesn't guarantee security. And as I showed, these flaws or vulnerabilities by themselves didn't have that much of an impact. That Sentry, if you keep your key secure, you're totally fine. But if it gets exposed somehow, it just breaks down. And server-side request forgery led nowhere except for maybe other servers somewhere. And let's assume those were all secure. If that other test server that allowed me to read the source code and find the read file test that was still left in there, if that test server wasn't online, that was it. Then I was done. But it's all these small mistakes that eventually lead up to me getting code execution within a network and basically free reign to go and look for something else. Maybe you try to log into the test server and I can intercept your credentials and go further that way.
Yeah, it's really a lot of small mistakes that, well, as you wrote down there, the fail chain. And even though we have this hard outer shell, the firewalls, the whatever is on the internet is probably really good and secure, at some point, you, your colleague, a system, a supplier will fail, make a mistake or anything, and your debug, your test, your whatever you're running internally that is, oh, it's only internally, might be the next line of defense that could make or break one of our big hacks.
So that was the demo, and I think all the lessons that we wanted to teach you.